Welcome to spheres, transparent spheres with intersecting elliptical planes, ideally looking as if they are at a 90-degree angle to one another. These are close, but not quite there, but close is good. There's a technique that I want you to use which gets us in the ballpark. It's not exactly there. The reason that this is really important to have this transparent sphere is because it really gets the point across of that objects have axes that indicate directionality, and that this is a lot what the one example is when cartoonists use this form with an axis and an axis to indicate the directionality of faces. They're looking this way, and this is the underside, and this is the side. And so this really starts to make us see how we can plot more organic forms in space, specifically the sphere. So sphere, like the ellipse, best to come from the shoulder and do it. I would say just try to get in the ballpark like this. Once you're fairly secure, you can do an XY axis thing. Just go like this and this and see if you're in the ballpark. I'm pretty much in the ballpark. And then you spin the thing. Then you can see where the anomalies are. Like this is kind of needs to be fuller over here to me, and this a little bit thinner here. So I'm going to try that. And look how not hard I'm doing it at first. I'm just kind of carving it out lightly, making sure there's fully inflated, there's no anomalies, but it's a several stage process. You don't just necessarily instantly come up with it. And the spinning really helps you to get a different perspective on things. It seems like it's distending this way, or maybe shallow this way. So I'll put that out a little bit more there. Okay, so I think that's getting in the ballpark. That's pretty good. So I'm just going to get rid of the extraneous stuff, which helped get me there, but I no longer need. It's like people who climb the corporate ladder. And we don't need you guys now. All we need is the pure circle. Okay, so I've got a fairly committed circle. And then what I'm going to do is just do an XY axis that's at 90 degrees. Again, maybe start thinking, well, where is the center? I'll estimate it there. And do a 90 degree for now. It doesn't work in all cases. And then what you're trying to do is create two different ellipses that intersect. And I think it's good to try to do it so that they're different obliquity. So if you take a point and put it in anywhere in one of these quadrants, and then you think of an ellipse passing through this point, and then going to hit that minor axis, and back to the major axis, and then an equal distance there to there, and this passes through there and there. You're starting to get a sense of the major and minor axis, and it's just finessing these things so they seem symmetrical on both sides. Now why I put this point here is because I'm thinking, okay, I'm going to do the same thing on this axis and have this start here and move out and go to that point. And it means it's going to be symmetrical over here in terms of the distance here is going to be there. And I'm turning my pad because the arc of my hand goes this way. And so what I have is a sense of this, these two intersecting ellipses right here. And I'm close to it. So what you want to do is, once you get to that phase where you feel like you've got symmetrical quadrants on all sides, you want to emphasize graphically like this, doing the outside line, and then the outside latitude and longitude lines. And then I want you to indicate also this intersection of the plane. So you think of this and this intersecting as if these were two pieces of paper put together going through the sphere. This comes out, this is the front side, and that would go out the back, and that's the back side. And so when you do the graphite, just like here, you're graphiting these things, making sure that your ellipses don't come to points, but that they finesse through even when they're thin, that they don't do a point thing. And just graphite the side that would be the object line that would show on the facing side. Okay, you get the idea.